right, this is going to look a little confusing for a second, but you look on there, what I have is I took a picture of what's on the screen. And the only reason I'm telling you that is, again, if you have some problems with this is going to be more lecture today than even looking at the book for these 2 hours. I don't know how long this is going to take. But what my goal is to sit there and go over what's in this stuff that's right here. All right? But I've also written it on the board. So what's going to happen is I'm going to leave that picture up there because that's going to show, all right? But there's no way I can do that. So let's see. I'll tell you what I'll do is I guess I'll have nothing up there. That's fine. All right. But what I'm going to do is quickly, hopefully at least, talk about this stuff. If you remember, when we started on this topic, I emailed you, or I didn't email, I had you take a folder that I had, and everybody copied it. You all copied that folder to your desktop or wherever you copy stuff. That's where this is from. All right? This is that sales order example. That's what this thing is called. But what I'd like to do here is to take a bit of time to go over this. One of the things is, if you start to go to work for a company, all right, I may have told you about this before, I may not have, you may not give a darn. But years ago, before the internet was what it is now, I graduated and got my 2-year degree, and I don't remember even what year it was. It must have been a good 30 years ago, something like that. All right? And when I got it, I applied for a job at a company. And it was real obvious to the guy who was interviewing me about 10 minutes into the interview, I had no idea what they made. And I didn't. He even said that. You don't have a frickin' idea what we make here, do you? And I said, nope. And he was like, wow, I should almost just kick you out right now. He didn't. And actually offered me the job later. If I didn't take it, I didn't want to do what it was. Right? But the point is, if you're going to go to work for a company, sooner or later, and in their eyes, sooner, you have to understand how the company works. All right? That doesn't mean that you understand every single facet of the company, but you have to have an overall picture. So let's suppose that you are going into a company, and the idea is you're going to work on the company's database. So that's what this is. All right? So for this sales order example, when you look at it, what do we have here? Well, we've got categories. Each category would have an ID. So let's assume, for example, let's try to keep this somewhat simple. Let's assume we're Walmart. All right? So let's say that category ID 1 happened to be clothing. Category 2 happened to be sporting goods. And we could make a whole bunch more. What I'm trying to get to is, does everybody understand this? That the category ID is going to be this number right here. And the description is going to be this right here. Does that make sense to everybody? All right? Because what I'm showing you here are just the names of the fields. But in the example that I gave you, all right, it's got all the stuff in here, they tell you the type of each thing. I didn't know how much board I'd need, so I didn't think I'd have the ability to write the data type for each one of these. Plus, it took 15 minutes to write this on the board anyway. All right? So we've got those. All right. Then Walmart has customers. Ideally in here, everything that's in here makes sense. All right? Each customer will have an ID. All right? Now, you might look at it and go, well, I shop at Walmart and I don't have an ID. Well, just play along with the game, okay? So that's the idea, that each customer that we have would have their own ID. Their own first name, their own last name, their own address, city, state, zip. Now, with the area code and phone number, you know, again, how important is that? I don't know. We don't have email address in there. There's other things that we could potentially add. But what I'm saying is, as far as what's in there, that is what we have for a customer. All right, so each one of our customers has that stuff. Hopefully you can look at that and know that'd be an int, that'd be basically a string, a string, a string, a string, a string, a string, etc. All that stuff. One thing you may or may not be aware of, for instance, the zip code here, so my knowledge, is 63385, right? But if you're going to take zip code and make that a field, you don't make it a numeric field. You make it a string field. When you work with databases, the only fields that should be number fields are fields that you could potentially use in a calculation. You're not going to use a zip code in a calculation, so you'd make it a string, just so you know that. Same with the area code, same with the phone number. So virtually everything in there other than the ID would be a string. We don't call them strings here. We call them chars if they have a fixed length, and we call them varchars if they have a variable length. Now, I want to tell you something that I haven't told you yet, and that is if you look on this handout, basically this thing I sent you, some of these, rather than varchar, they say n varchar. Now, I'm not even sure what the n stands for, all right? But the idea behind using those, yes, sir. I can check this afternoon. It very well could be. Okay, thanks. So what I want to be sure of is that you understand what all this stuff means. The n varchar means that you can use the Unicode character set. In other words, you'll be able to cover different languages. I have no idea if Walmart has different, locations throughout the world. Knowing the fact that they're Walmart, all right, and they're probably as greedy as Microsoft, they probably do. So the N would basically allow us to use the Unicode character set. My question is there anything in here or in here that doesn't make sense to you? Anything? All right. Then these are the employees of Walmart. You notice it looks almost basically identical to the customers, except instead of saying cust, you say emp, and instead of a customer ID, you've got an employee ID. Okay? And, hopefully this makes sense to you. My wife actually has a very good friend who is a checker at Walmart. All right? And when you think about it, an employee can also be a customer. That makes sense? All right? So an employee can be a customer. Does that mean a customer can also be an employee? It sure looks like it. All right? But we don't really care that much about that relationship. All I'm trying to do is just be complete here. All right. Then, customers have orders. Each order, so we're going to assume that these customers, let's just say this is Walmart Online. In fact, doesn't Walmart have that thing now where you can actually, they got two things they've added. One is that I think you can call in your order or email it in and they'll give it to you. All right, you can drive up for it. The other one is, and I just saw this recently, they put scanners on their shopping carts. So the idea is I think you can scan as you're buying things, and then you can just go up and basically be done virtually when you go up there. I haven't tried that one yet, but I always use the I don't drink, which makes this much easier for me, but I always use the scan and go yourself. All right? There are very few idiots who go into that. But most idiots, and if this is you, sorry, but most idiots are the people who have their credit and debit cards and don't know a thing about how to use them. And they frustrate the hell out of me, so that's why I go in there. So, you said there's nothing about categories, customers, or employees. You get it all, right? So, customers place orders. Each order will have an order number, a date it was placed, a date it was shipped, a customer ID, so we know who ordered it, and an employee ID, so we know who took care of it. Does that all make sense? You can already see there's going to have to be a link between here and here. Does that make sense? There's going to have to be a link between here and here. Does that make sense? All right. That's how we're going to be able to relate this information together. Okay? So, each order has details. So most people probably are going to order more than one thing. So the order is going to be the culmination of all the order details. Does that make sense? So all these details must be associated with an order number. Well, they have some kind of a product number, they've got some kind of a price, and they've got some kind of a quantity order. Does that all make sense? All right, so you can already see, well, we're going to also have a link between here and here. All right, and products, product number, so you can see we're going to have a link between here and here. All right? Each product has a number, has a name, has a description, has a retail price. So remember, this is for the customer. That's what the customer will pay. It has a quantity ordered, and it has a category ID. We already linked up the products with the order details. All right, but you can see category ID. Now we got to come in here. We got to link up that one with this one. Does that make sense? So you start to see, hopefully, how everything starts to kind of come together. All right? Each product comes from a vendor. So you can see, again, there's going to be a link between products and product vendors. Each product vendor has a product number, a vendor ID, a wholesale price. A wholesale price, which means, again, that's going to be what the, so in other words, if Walmart is going and buying stuff in mass from Pepsi, it's going to be the price they pay. It's not going to be the price they charge to a customer, but if they're buying hundreds of thousands of cases of Pepsi, they're going to get it cheaper than you and I are going to get it. That makes sense? All right, and again, if it doesn't, think about it this way. I'm always amazed. My wife will go and say, I went by this jewelry store, and their stuff was 75% off. I said, did you buy anything? Well, I bought a couple things. You know what? They're still making money on it. They are, by and large. It's very, very rare that a company will take a loss for things. Occasionally they have to. All right? So the product vendors have all that stuff. And finally, we've got the vendors. All right? So notice the vendors have a vendor ID. So you can see there will be a link between this and this. All right? I just put those dashed lines there. But ideally, what you see is there is not one table in here that's in an island. In other words, I can link together any of these 8 tables. Now, if I want to link together, for example, customers and vendors, let's just say, I don't know why I'd want to do that, but if I did, there might not be a direct relationship. But I could go from customer to order, let's say to product vendor to vendor. So I can get there, is what I'm telling you. That's what you have to realize. All right? So on this, and it's gonna look really ugly on here, but I just want to show you this. This is the thing, you can't read that I gave you. But this is where I took all that stuff from. So you have this. That's what I'm telling you. All right? Because eventually what you're going to have to do is you're going to have to join together this information to be able to get information. All right? And what I'm saying is you're going to have a worksheet that I'm going to give you on Friday. Some of the questions in there, you're going to answer them in like 10 seconds. You'll probably get about 10 of those. But you'll also get about 10 of these, which are going to make you think a little bit, because you're going to have to combine information together from multiple tables. All right? That's where database people start to make their money. All right? And some of these queries that we end up writing end up being really, really big. All right? I had a student years ago, may or may not have told you about this. His name's John Sissons. He went through the program at Blackhawk with me, and he got a job. He loved databases, and he was like you, Ethan. He just went nuts over them. All right? And he was really good with them. And he got a job with the Wisconsin Department of Natural Resources. He was a database programmer. And I asked him, I said, what's the longest query you ever had to write? And he said, you're probably not going to believe this, was 11 pages long. A single query. I said, 11 pages? He said, I was going through many, many millions of records looking for one thing. So sometimes you have to do that. You have to be that granular when you're looking for something. All right, so that's the first part. Then at the end of this, and again, I realize you can't read it, but we'll go back and look at it later. That's where we got all these constraints. So I want to show you very quickly what at least some of those constraints are. First thing is, if I said to you, let's suppose you had your C# book with you, okay? And I said, today we're going to talk about delegates. And you said, didn't we talk about those before? Geez. And I said, turn to the page in your book that's on delegates. and I didn't give you a page number, what would you do? You'd go to the index. That makes sense? That's what I do, is I go to the index and I look up either delegates or C# delegates. Because what is an index? It's kind of like a dictionary, isn't it? With a dictionary, if I want to look up the word fantastic, I go to the F's, I go and eventually find fantastic. That's the key, and the value that's in there is the definition for fantastic. An index works much the same way. It sets it up so that it's easier for the system to go and do things. Why am I telling you that? Because many of the things that are on here create indexes. All right? Why do you create indexes? To make your life easier. So when you do joins like this and when you do queries, they run faster. Your queries are running in 0.00 seconds because we had 8 records. Imagine that we had records of everybody who has ever come to Rankin. There probably would be several thousand, I would think. You know, any student who has been here ever, there probably maybe would be over 100,000. Now it wouldn't be as easy to work with as 8 are. All right, so some of the things that we do in here. First of all, and some of these should just make sense. What I'm going to do is I'm going to come up here and I'm going to put a P here. I'm going to put a P here. I'm going to put a P here to start with. Those are primary keys. All right. Sometimes, literally, depending on the software that you use, it will literally show you a little key there to show you that it's the primary key. But what we're saying is each category, that number that's in there must be different. Must be. Each customer, that number that's in there must be different. Each employee, that number that's in there must be different. Does that make sense? All right. I showed you yesterday, okay, and Ethan, just so you know, when we first created it, we created a very simple database where I put all 8 of the people in the class in here. But when I did it, I did not create any primary key. And I showed them yesterday how to go back and use an altered table to add a primary key. All right? Actually, to modify an existing field to make it a primary key. Now, when you look in here, probably at least, I'm looking at this, is that's going to be the primary key. Does that make sense? But if I look in here, this by itself, this is probably not enough. All right? I probably need both of these. That is called a concatenated primary key because it's made up of more than one field. All right? The reason I'm telling you this is we're going to start creating our own tables, and when we come in and start to create our own tables, you have to understand the syntax when you create these, because otherwise, you know, this is setting up the schema. When you set up the schema, it won't work. And if the schema doesn't work, you're not even going to be able to put in the records that go with the schema. All right? Then we've got products. That's probably going to be a primary key all by itself. Product vendors, it's probably going to need both these two. So that'll be a concatenated primary key. And the vendors, that'll be the primary key. All right? So with what I've explained to you so far, we're going to go back and look at it in the confines of the book. Does that make sense? Is there anything in there that doesn't make sense? Right? I don't mean that now you understand that this is Walmart, that you totally understand how Walmart works. That's not the case. All right? And I think that Ethan will attest to this, and please, if you speak up if you don't agree. What we did last fall was we had a woman come in here from the St. Charles County Economic Development Center. And she came in and tried to explain to us how their entire system was set up. And she drew a lot of stuff that wasn't exactly this, but it was similar to this in nature. All right? And then Ethan and the 2 members of his group created something like this. They had a bunch of stuff already done. Some of it was thrown in Access, which is a watered-down version of a relational database management system. It's a cheap little Microsoft product that goes with Office. Some of it was just in spreadsheets. Some of it, we have no idea where the hell it was. All right? But the problem was, this woman who was telling us everything They went and did something like this. Oh, I forgot to tell you, this is also over here or whatever. And she kept adding things. Or, oh, we don't use that anymore. Then they had to remove things. So the idea is, before you put data into a system, your schema should be in good shape. All right? All your fields should be identified. The field types should be correct. The field names, you should have some kind of a structure where there's some kind of a protocol that you're using. So notice what the author did here. Category, customer, etc. Employees, employee, etc. Then they broke it right here. I mean, they could have really put here order number, ord date, ord ship date, ord custom, etc. Why would you want to do that? To make it easier to understand. All right, well, it's longer, yeah, but then you'd know this ord customer ID goes with orders as opposed to that customer ID. All right. Sometimes what's going to happen at some companies, what they do is every single primary key is a field just called ID. Period. That's it. ID. So this would have one called ID. That would have one called ID. That one would have one called ID, etc. So when you want to join those together, if you want to tell the system which one it is, you have to say like categories.id, customers.id, employees.id. Otherwise, it won't make any sense to the system. All right? And I've said this before, the way that the software works, if the software doesn't understand what you're trying to do, it's not going to let you do it. So you can have the best idea in the whole world. Oh, yeah, I'm going to do this. I'm going to get all this stuff. But if you can't put it in a way the software can understand, you're not going to be able to do it. All right? And what we're trying to be able to do in here, maybe you've heard this saying before, we're mining data. All right? You may have heard that concept of data mining. All right? Some of this stuff, I mean, what's in here wouldn't be hard to do. But if you imagine, let's just suppose for a second that Walmart literally has a copy of every single transaction that's ever occurred there since they've opened up. But let's say that from 1990, I don't know when they opened, but let's say from 1990 to 2010, all the copies they have are paper. All right. Well, this isn't going to work very well. They'd have to find a way to digitize it and then be able to use it. So why would you want to do something like that? All right. A lot of different people use this information when you're data mining. For instance, marketing might want to go in and take a look at orders. And they might want to see, oh, you know what? When it gets to be this month of the year, maybe October, maybe November, people start ordering a lot of winter jackets from us. All right? So they know that when that month comes, they want to increase the orders of winter jackets. Whereas when June comes, wow, now in that month, orders of swimsuits spike. That kind of an idea. So marketing people want to know that. Not only do marketing people want to know that, their bosses want to know that. So they know how things are done. All right? When you look in here, and if, when you've got employee ID, etc., you might realize after you look at it for a while, we've got this employee in here, Evan, and he's one of our employees. He's selling a whole bunch of stuff. He's at this store, and why is it that out of all the stuff that's being sold here, he works 40 hours a week, 25% of everything that's being sold here is being sold through him. Maybe he works in sporting goods. And when he's working, well, then they say, you know what? We don't want to lose this guy. Maybe we ought to make him a manager type of an idea. So that's all stuff that you can find by looking at that data. All right? So anything, because I'm going to erase this, anything that I put up here that doesn't make sense, anything. And again, this was just meant to be a high-level, global type of view, and that's it. this diagram that I just wrote up on the board here, although it's very simplified, is typically regarded as an EER, which is an extended entity relationship diagram. And all the different stuff in there, the categories, the employees, etc. All of those were entities. So what we're trying to do is we're trying to diagram the flow of information through here. That's exactly what we are attempting to do. All right. In fact, you can go out, for example, I can go out here. Let's see, not there. There's a different example of an EER diagram right there. Now, you don't have to worry that much about these symbols. We'll talk about them a little bit later. All right. But what it all boils down to is when we talk about this, let's go back to here. With these relationships that we mentioned before, again, there are three different types of relationships you can have. You can have what are called one-to-one relationships. You can have what are called one-to-many relationships. And you can have what are called many-to-many relationships. All right? Well, a one-to-one relationship, the easiest way to think about that is, and again, no jokes about Utah or anything else, but typically one husband, one wife. Right? That's a one-to-one relationship. All right? If you would talk about, for example, when you talk about the relationship between a parent and children, one parent can have 0, 1, or more children. All right? A parent can have a child and the child can die, so the parent technically has no children anymore. All right? So with a one-to-many, this is one-to-one. This is one-to-many, which many here means 0 or more. All right? You can also have many-to-many. This is the hardest for you to be able to diagram like this. All right? Many-to-many doesn't work well with relational database management systems like we have. So you end up breaking this down into a series of one-to-manys. We're going to go into that in just a bit. All right. So that might have been a little long-winded, but I wanted to go through that so at least you've been exposed to what this stuff means. All right. So with that said, then I'm going to jump back into the book, and we're in. Oh, I got back to the beginning of it, but that's fine. If you're following along, I'm on page 113. All right. How to retrieve data from 2 or more tables. When you retrieve data from 2 or more tables, it's called doing a table join. And I'm going to show you some examples of table join in here. All right. I didn't send it to you yet, but I wanted you to know something. I went out to Muroc's site today. This is a Muroc book. I went out to their site today, and I requested a copy of all of their stuff that they have. The reason I'm telling you that is, and I got to email it to you, but what I have, and I've got it already in a folder, but I haven't done anything with it yet. It's a folder with today's date on it, so it's in here someplace. There it is. All right, there are 3 files in here. Actually, it came as 1 file, but I broke them up into 3 because I thought it'd be easier. These are the databases that they use throughout their book. So I'm going to give you their databases. All right, and again, so let's say, for example, this one right here, it's called AP. I'm going to do a Control-A, Control-C. All right, get back into here, get back into here where I am, and right mouse click. That's it, and now that database is on my system. It's called AP. So if I do my show databases, notice one of the ones that's in here now is AP. I just added that. One of the other ones is called OM. I added that one before. The other one is called EX. So again, I can come back here. I can find the one that's called EX. There it is. I can bring it up here. Control-A, Control-C. Go back into here. Right mouse click. And literally, in about a minute, you can come in and you can add all three of these. Whoops, show database says. You can add all three, and you can have those yourselves. All right. The reason I'm telling you that is in the chapter here is where they start doing some joins on these different tables. You understand what I'm saying? So when you're going and doing your homework and you get confused, you're able to go back and perform some of these joins as they're shown in the book yourselves if you want to do that. All right? And it's funny. When I decided to teach it like this, and I'm making some changes already from when Ethan took the class with me a year ago. But that said, I always got the feeling in there, as soon as some people in the class heard, what, no tests? Just some assignments? They were like listening while they were playing games, or they were listening while they were just checking their phone quick or whatever. All right? But again, I've said this to you before. I'm not going to stop saying it. When you think about it, there are a lot of avenues for you to get a job when you come out of this program. One of the main ones is web design. All right? One of the other ones is programming. But one of the other ones is you could go out of here and become a database designer or do some work with databases. Even if you're going to be a programmer, the chances of you never having to touch a database are almost none. Every place that captures information and wants to keep it uses databases in some way. All right? You will be using databases next semester when we start doing ASP.NET. In fact, the book that we're going to use, and I might have told you this before, all right, that book, that you literally build a store, and it's a store for a company that sells baby items. All right, baby items. I didn't pick out the book, okay? And the book is okay. There's nothing wrong with it. But the idea is we're going to build a full-fledged online store that you could go and put out on the internet if you wanted to. All right, but it's going to be backloaded via a database, because if it says there that you've got 50, let's just say, I don't know whatever, kids tricycles, and Tony comes in and buys one, you'd want to make sure that the inventory went down by one. That kind of an idea. All right. So as it says in the last chapter, you learn how to create result sets. What's a result set? If we did this before, remember how many times did you see me type in select star from students? Whatever comes back, that's a result set. Does that make sense? All right. And a result set is temporary. In other words, if I come in here and I go in and I use Rankin, the one we've been working with, and I say select star from students, boom. That information came on the screen, but it's gone now. If I want it, I've got to run it again. What we'll get to in a later chapter, just so you see this, if I type in create view X as, all right, it says nothing happened. Yes, it did. Now notice what happens when I say select star from X. See that? We're going to learn how to create a view, and all a view does is it saves a query for you. And all a query is it's something you run against a database, and the information that you get is called a result set. The result set is temporary unless you save it like that. All right? So it says, this chapter shows you how to create a more advanced result set. It does by having you take and combine information from 2 or more tables. And you could join, if you remember that picture we had up there, all right, you can literally come in and you can join together as many of these as you want to. We could literally write something where we join and grabbed one field, let's say from categories, one from customers, etc. And probably, maybe not today, but maybe tomorrow, I'm going to draw something like that for you. I'm going to create that where we, it may be, like, why would you do that? Just to show you can. All right? And the other thing, too, is I'm going to show you 2 syntaxes for doing this. The one that's used in the book is considered the syntax you should use today. Do you all hear me? All right, the second one that I'll show you, I believe it's also shown in the book, but they just in passing. Remember, when I learned this stuff, again, it was somewhere around 30 or so years ago. This is what I did my thesis in, all right, for my master's degree, all right, was on databases. And the reason I'm telling you that is they didn't have this new syntax for doing it. So I'm used to using the old syntax. So I'm going to show you a lot of things using the old syntax. When you do your homework, I don't care which syntax you use. I care that your answer is correct. I gave you this example before. It's like if I say, hey, we're meeting at the St. Louis campus tomorrow. I don't care how you get there. I do care that you do get there. All right? So I'll show you two ways to do the same thing. You can pick the one out that you're more comfortable with. And do I have a preference? Yeah. The old way, because that's what I learned. But I have no problem at all going through the new way and showing you that. So the majority of the work that you do, when you join together tables are what are called inner joins. And there's a special kind of join that's called an equijoin. Equa meaning equal. And when you do an equijoin, that says, hey, I want everything that's in this table and in this table where they're the same. Okay? But we'll also talk about what are called outer joins, okay, and different ways that you can do outer joins, and we'll talk about unions. All right, so we're going to get through all that stuff. I would like to get through as much of the stuff today as I can. At 9, we're taking a 15-minute break, and I'm going to come back and I'm going to lecture from 9:15 till 10. All right? If we finish the chapter in that time, great. If we don't, it's fine. But then tomorrow morning, I'm going to go over chapter 5, which is the last chapter in this part. You with me? All right. And then when we get done with that, I'm going to give you your first worksheet. I'd like you to try as much of this stuff as you can. Some of you very well could struggle. All right. I'm here to help you. Ethan is here to help you. And Ethan is a bright guy. He knows what I'm about to tell him. He's already heard this before. Don't go over to Ethan with a blank piece of paper where you've tried nothing and say, can you do this one for me? That's not his job. His job is to take, when you've tried to do something and you have a problem doing it, for have him to go walk through what you've done, show you what you've done right, and show you what you can improve. All right? So, how to work with inner joins. Again, a join allows you to combine things together from tables. Now, that said, and I want to make sure you get this from the beginning. Again, if you look on the screen here, all right, let's say that I wanted to combine categories and customers. See that? Categories and customers. Right now, I can't do that. Why? There's nothing in common. Technically, I can do that. But I get back garbage because there's nothing in common. There's nothing to do a join on. All right? I mean, I could come in here and try doing that. So let's see. This is sales orders example. All right. So there it is. Select star from, what was it? Customers, categories. I don't even know if it's going to say this is legal or not. It's giving me every possible combination there is. All right, well, how did I get to 162? Well, to show you, there are 27 customers. There are 6 categories. 27 times 6, 162, right? So it put together every single combination. Now that's all fine and dandy, but the thing is, that's nonsensical. It doesn't make any sense because, as Josh said, there's no field in common between the two of them. So to do a join like that, that's called a Cartesian product join because it takes the maximum number of rows you have in one table, multiplies it by the rows you have in the other table. That's how many results you get back. All right? It wouldn't make sense to put a where on here. I mean, we could run this and say, for example, where categories equal 5. All right, well, let's see. Select, oh, I'm sorry, it wouldn't be for categories equal 5. Select that where category ID equal 5. All right, it still doesn't like something. All right, I got to get the right name. You're probably, yeah, okay. Well, let's check and make sure I spelled it right. All right. So I could come in here and say that. You're right. I could come in here and say select star from this, where categories dot category ID equal 5. Notice I only get 27. Why? Because there's 6 categories. 6 times 27 is 162, but I only wanted one of them. Divide 162 by 27, or by 6 rather, you get 27. All right? But what I wanted, the reason I put that up there and what I wanted to show you with that is if we look at the syntax, all right, that's called an equijoin. We're grabbing everything where they exist in both of them. Doesn't make a whole hell of a lot of sense, but you can do that. All right. So, again, a join allows you to combine 2 or more tables into a single set of information. So they start to show you some examples here, and they go like this. That's more or less the overall syntax that you see on top, but let's take a look at an example right here. This is one of theirs. This is not the sales category, but this is one of theirs. So what is it saying here? Select the invoice number. All right. That's probably going to be from invoices. Select the vendor name. That's going to be from vendors. See that? Now, there's nothing wrong with what they wrote there, but let's take a look at what they wrote. All right, I'm going to grab it. Yeah, put it here, that's fine. This is what the author wrote right there. I'm going to replicate it here. A little smaller. So the author has here, select invoice number, vendor name, from vendors, inner join, invoices on vendors dot vendor ID equal invoices dot vendor ID order by invoice number. All right, so let's just try to see if we can make a little sense of this. All right, again, this field more than likely is coming from here. This field more than likely is coming from here. Do you all agree with that? Those 2 tables have a field in common. One of them is called, they're both called vendor ID, and that's, was it? This is vendor underscore ID also. All right. So they're both called the same thing, so I have to let the system know the names. See that? All right. If I wanted to, I could rewrite this query like this. You might think this is overkill, but this is the way a lot of database people write their stuff. Invoice, whoops. Select invoice, invoices dot invoice number, vendors dot vendor name from vendors, and then do that. See the difference? I'm putting the name of the table dot the name of the field. That's leaving no doubt in what I'm looking for. All right? Even that, you might look at that and go, okay, fine. All you did was you made us do more typing. Isn't there a faster way to do that? Yeah, and I'm going to show you that too. We're about to take a break. But I just want to put this in here just so you get exposed to this stuff. That's all. So this query right here could also be written like this. Okay? I'm going to put here an I dot, and I'm going to put here a V dot. All right? You may or may not remember this, but yesterday we talked a little bit about aliases. I've just aliased these. I said, hey, instead of calling it vendors, let me just call it V. Instead of calling it invoices, let me just call it I. I don't know if you agree, but it results in a little bit less typing. But as soon as you say that I'm going to do this, as soon as I'm going to alias them, I have to use the alias all over the place. I can't use vendors dot anymore. I can't use invoices dot anymore. I have to use I dot and V dot. Even though I didn't define them till down here, I can use them up here. All right? So you just have seen, it's very simple, might not seem like it, but it was. These are, I gave you 3 examples of doing the same join. And as the author says here, a join combines columns from 2 or more tables. All right? A join condition is the condition where the 2 are equal or not equal or whatever. This is our join condition right here. Inner join invoices on vendor where that stuff is equal. So that's our join condition. As it says here, tables are typically joined on a relationship where you take the primary key in one table and you put it into another table. What the hell does that mean? Again, I'm going to go back to that picture I showed you. All right? And you notice, for example, here we've got order number and a bunch of other stuff. Everybody see this? Well, so we can relate orders with customers. Notice how we've got customer ID in here? Customer ID was put into this table so that we were able to directly relate the orders table with the customers table. All right? That's why. Right? All right, I just showed you the aliases and how you can use those. It's possible to join a table from one database with a table from another database. I want to say that again. I can join a table from database A with a table from database B. And remember before I just showed you this, how you can use this stuff, the name of the table, dot, etc. That could have been the name of a database, dot. You don't normally combine information from 2 different databases, but there might be a very logical reason for doing so. All right, it's not done often, but again, you could do it. All right, it's 9. Let's come back at 9:15, and we'll talk about how to use compound join conditions.